We need to unmute.
I've never done this before,
Right?
The mic
First
mic-
time. Well, I'll teach you how to do.
Thank you. Yeah, this is I don't know. Where are we? So we're in
Denver, Colorado, suburb of Denver. That it's called Pine something.
right,
Denver.
right, and that's fine because they're both nice places. Last week we were at Dev 2 Next,
Yes.
which was
No,
built.
that's the.
No, sorry. Last week we were in JConf.
jconf.dev.
Dev. Yeah.
And this is Dev,
Dev 2
to
next.
next.
Yeah.
Not confusing at all.
No. Especially
no.
one right after the other.
Yep.
But and then that show was billed as being in Dallas, but it's actually in a suburb.
Right,
Called
in
Allen.
Allen.
Yeah,
Yeah. Which almost sounds like Austin, which is also not confusing
It's
at all.
not at all confusing.
Yeah, no.
Anyway, so you and I are here at Dev 2 Next, or as I've taken to calling it, VenCon.
VenCon.
Right.
Or is it VenConf
VenConf?
or VenCon?
VenCon, yeah, it's Dr. Venkat Subramaniam's show
Yes.
here in
Denver. We
Denver.
decided
Yeah.
it's Denver.
Yeah, it's not Denver, but
Pine Creek, Lone Creek. Yeah.
Yeah,
Denver.
So we're here. I'm Josh.
Hello,
Long.
Josh.
Hi, and this is Baruch Sadogursky. I always pronounce it
Nailed it.
Sadogursky. I got it wrong.
Nail it.
I've been
It's
doing
okay.
the
I'm not-
dyslexia.
Yeah, no. I try to get easy on people. So my Starbucks name is Bruce because I don't want people to suffer with weird names.
That's so sad, man. I'm so sorry.
Why?
So
No,
sorry.
I'm fine.
Oh man.
I am. So, side story. This is all we're all about. Fingers crossed, going to get my U.S. citizenship soon. Yay!
Oh, thank God.
This
we
is-
need you.
Oh, this is so awesome. I'm so excited. It's a topic for like a different discussion. on its own.
Congratulations to
Thank you.
us.
Thank you. But what I wanted to say here is that I'm putting Bruce as my official middle name. So it will be Baruch Bruce Sadogursky.
Oh, that is the best. I don't. I gotta tell you, I wish you had just saved that for the end of the show
Right.
because it's all downhill. From there.
No. We're going
That
to
is the
talk
best
about new
news
stuff.
we're gonna get.
Well, it's not news that we
Uh,
just submitted it and it took forever. And when I will get it, we'll celebrate, I promise.
Okay, I look forward to it.
Yes. So
Um,
I don't want to jump the gun. It's just story about Bruce. But anyway, let's talk about technology.
Yes. Look, I don't actually like technology. And the reason is because it is a means to an end, which is solving problems
For humans.
for humans.
Absolutely.
And so really at the end of the day, anything we can do to make those humans more, those developers especially, more productive,
I'll tell
with
you
the power of engineering.
exactly. I'll tell you why I do love technology. I do love technology
Okay.
because of two things.
Yes.
The feedback loop is very consistent and very reliable. You write code, it's either working or it's not working.
Yeah, that's almost true. Yeah, that feels like it's true most of the time.
Yeah,
Entropy being
It's-
excluding that. Yeah.
yeah, no, but it's but accounting on, you can account for that.
Sure.
But it's generally compared to people, for example,
Yeah. Fickle.
right?
Yeah.
So, how do you do it? You write code, you build code, and then you get feedback.
I mean, I hope so. Yeah.
Yeah, and that's again very close to getting feedback for you're learning to play golf
Right.
and you whatever punt or drive or whatever terms are used there, I have no idea. And then you get feedback either the ball goes where you want it to go or not.
Right.
So yeah, no, this is nice.
It feels like it's nice.
The
yeah.
problem is when you don't get feedback or when you wait too long for feedback and then it sucks.
And you know where I get the most delay? So okay, you and I are lucky. We live in this nice world of software on the internet and very fast tools and
Yep.
obscenely fast computers and all
Yep.
that. And I remember our foremothers and forefathers wrote code in terms of mainframes or these microcontrollers that you'd have to compile it and ROM and flash the disk and flash the device, try it out.
Right.
Because if it didn't work, you try again and the whole process.
And then for the mainframe,
Yeah.
you needed to sign up for the
Right.
time on the mainframe in
Yeah.
the lab, and it could be half an hour in 3 days from now.
Right.
And then you try to
if-
compile it in your head because you will only have half an hour to
Right.
actually test it. That was terrible.
And if it didn't work, then you're like, okay, I guess I'll come
Next
back in
time
3
in
more
three-
days.
yeah, 3 more days.
So that was painful. But nowadays, you and I are blessed. I think we have really pretty fast cycles. WebSphere notwithstanding.
What?
Yeah, exactly. That was
Yeah,
a bad cycle. But I mean, pretty fast cycles. That said, if you're doing what we all know we should be doing, which is writing lots of tests and signing your code and validating it and doing all these things, then we've kind of, for good reason, we've gone backwards in terms of that cycle time, right? It's now bigger again, right? And especially if you have distributed systems, there's a lot of moving parts.
So there are two types of feedback that we need to clearly separate and then acknowledge they are very different, right?
Yeah.
We have synchronous feedback that we wait for while we're writing code. I will give you an example, IDE.
Yes.
Right, you write your Spring Boot application in your IntelliJ, and then instead of Spring, you type string.
Right, and the idea is like, nah.
Right.
There's no string application context. There's a Spring one. Did you want that?
Immediately. Right. This is feedback that you get. You don't wait for it.
No, yeah, it's very nice.
Right, and then the other type of feedback is asynchronous. That is by default will take time.
Yes.
That will be your CI.
Right.
Right, you submitted your code. It will take, maybe it's a pull request that needs to be reviewed by humans, and then like all bets are off.
Right.
But even if it's like automatic CI, it will take like whatever minutes, half an hour.
Yeah, exactly.
You don't wait for it. You do something else.
But also, since that is my path to production, I do really want to know if it got through okay.
Absolutely.
Right?
But you don't sit and stare on the log, do you?
Because I do, because I don't know if I can relax or not. Like,
and I'll tell you why. Because you don't trust your build.
No, I don't trust everything after my build. The wilds of the changing sands of the Kubernetes cluster.
This is because your build doesn't check enough.
I mean,
this is why you don't trust your build.
I deploy to the cloud. The cloud can change underneath me. My build is the same. I trust the build, right? Like, it's just, I want to see it get deployed.
If you no, of course you want to see it. But if you trust your build enough,
yes,
you don't sit and watch the log of CI, right? You do something else. Obviously,
okay, you're right. I don't actually just sit, but I do. I can't focus 100%.
Yeah, no, of course. You will come back and see whether it passed, whether it failed.
Yeah.
It's fine. But you don't wait for it like you wait for your
oven,
your IDE to see if what you typed is correct or not.
To be fair, the timelines are also very different.
But this is exactly the point.
Yeah.
They should be different because one is synchronous feedback and other is asynchronous.
Right, and you get a lot more.
Another example of asynchronous feedback is production.
Yes.
Right. Your code went to production. And whether it's worked there or not, whether I had bugs, whether people like it or not, it's all feedback on your application.
Yeah.
Do you want to know of it? Of course you want to know of it. Do you like sit patiently? I need to check Twitter and see if people complain. No, but if
my God, what is it? You've got a lot of feedback on that watch.
Yes.
That's
an awesome watch. Yeah.
Whoa, yeah. That's a control panel. That's
it.
You could launch a rocket with that much information.
That's for sure.
Whoa.
And the computing power as well. Yeah, that's
anyway, but you're right.
But
Okay.
So remember two types. Synchronous
Asynchronous.
should be very fast because you wait for it.
Right.
And if it's slow, you are going to be super pissed.
Well,
I'll give you an example.
Yeah.
Slow build.
It's the worst.
You see? Now, why? Because build is still synchronous feedback. You want to wait for it to finish before you know what you are doing next.
Right.
Whether it's good to commit or there like a test failure that you need to go and fix. So build is this in a synchronous category,
but it takes a long time.
If it's slow, it's really, really annoying.
Yeah, and that's the other thing I was talking about. Like, so okay, there's two kinds of builds. Today, when we talk about builds as in I can git commit and git push it, we mean tests plus compilation, right? But now we have Gradle VM. So even just compiling can be kind of okay, I guess this is my life now. I'm just sitting here waiting,
right.
Yeah,
so,
just forever.
Yeah, someone mentioned the clips. Obviously, no. I mean, we are here all for using the productivity tools that you prefer. Right. If Eclipse works fine for you, it will be the same. If you type in Eclipse Spring instead of string or vice versa, you will get immediate feedback as well.
Yeah.
Right. And it's the same with build. Either you will use Gradle or Maven or whatever. We are talking in the principle here that when the build is slow,
it sucks.
It sucks because you want to wait for it. Now, let me ask you something.
Okay.
Tell me what do you think about what slow build is? Give me a number. Like annoying slow build.
For tests or just compilation?
So first of all, there is no different types of build. You do local build, and hear me out. it's a controversial take, but hear me out.
Hot take, spicy.
Hot take, spicy take. You do build to get as much feedback as you can
Sure.
before you send it to CI.
Okay, so it's the build I need to do to go to CI.
Right.
Okay.
And that should be your only build. You need to run it every time. If it's so slow that you prefer to skip tests, the problem is with your build. You need to fasten it up. You need to speed it up, right? But the build is what you try for definition of build. Build is the check that you do before, as synchronous, before you commit and go to asynchronous build.
Right. Okay, but
to asynchronous feedback.
So I don't run my integration tests locally.
But you should. That's exactly the point.
I do that in CI. I'd rather let that go off in the background.
But this is what this is why your actions about CI. You're like, it's kind of still something that has a very high probability of failing.
Well, of
because
course.
Because your local build is not comprehensive enough to give you the peace of mind that you deploy to CI and they know something else. Now, this is very bad for your productivity because, as you mentioned, while your CI running, you cannot concentrate on anything else.
Yes.
Because you are not, you don't have enough confidence in whatever you shipped. But you should. Your local build should give you this confidence.
Yeah.
And CI is just another layer of protection.
Okay.
So the ideal path, your happiness, your development happiness is you're at your code in ID. It fixed everything for you that could be fixed.
Yeah.
You run your local build.
Yeah.
It runs very fast and gives you the confidence that 99% of the times it will pass CI. And then you commit and you're done. You are up to doing something else with full concentration on the new task. Whatever you shipped won't bother you. Yes, sometimes it will fail.
Yeah.
And it will be very annoying because you know what, you already forgot about it and you're out of context and what's not. But it will happen rare enough that the majority of time you will enjoy this bliss knowing that local build gave you the quality high enough that you are confident that the CI will be fine. So that's the goal. Now, is it the current situation? Of course not. And you are the proof that it's not.
Yeah.
When you tell me, okay, I have not really one build, I have multiple builds. In some build, I skip tests because, you know, otherwise I will wait forever. And in some builds that don't even have the needed tests because, you know, it's just insane. It will take so much time that it doesn't make sense.
Yeah.
Now, all those symptoms that your build infrastructure is not good enough and not that this is how it should be. And speaking about developer productivity engineering, after all this intro, let me ask you if the following makes sense.
Yeah.
If we engineer your local build to check as much as possible in the shortest time as possible, because remember, it's a synchronous build, will your developer productivity go up?
I mean, if I can have all the information quickly, then yeah, of course I will.
Exactly.
But
so this is what the main tenet of developer productivity engineering: foster faster feedback. I love it. Say it fast. Foster faster feedback.
Foster,
like fostering something.
Foster faster feedback. Okay, yeah.
Foster faster feedback.
Yeah.
Can you do it?
I just did.
No, it was very slow. It belongs to it.
Foster faster feedback.
And now foster faster feedback.
Foster faster feedback.
Foster faster
feedback. No, okay. Anyway.
Good job. Right. So foster faster feedback. This is the main tenet of what we are talking about, developer productivity engineering, because as you can see, it's very important for your productivity to be able to do that. Does it make sense?
Yes.
All right. You have some thoughts, objections,
I'm
comments.
So,
let's do it.
Yeah. Okay. So the integration tests by definition involve other components, and so I actually prefer letting that run in CI just because I don't want to have to spin all those things up, you know. And you know, I've got a humble laptop. I can run Slack and Chrome.
And that's all.
And that's about it. I can't.
Yeah.
Only 128 gigs. There's no
Yeah,
way I can run.
yeah, we need to be reasonable.
Yeah, so we'd be reasonable. So there's that. And then, but on the other hand, I think what I was trying to lead to was that I want the smarts of the velocity to make sure that when I run the builds locally, I run the tests only those that have been impacted.
Right? We're getting to it.
And so I was trying to like get to that, but even in that scenario, I still think because at the end of my running my local tests, there's kick off these other pipelines to make sure they're all integrating correctly.
So first of all, you're 100% correct, right? Obviously, local build shouldn't be a replacement to CI, right? It's not that I'm now engineering your local build to be so awesome and you trust it so blindly that you can just release from your laptop. No, this is not how it's supposed to be. CI is there to really remember what CI stands for: continuous integration, right? So it's really there to check the integration parts. Right? So that makes sense. But if you can take those components, those dependencies that you have, your databases, your queues, your whatever
other microservices, other
code bases, and run them to a certain degree in your local build without overwhelming your humble M3 128. I mean,
poor thing.
without overwhelming it because it has to run Chrome and Slack on top of that.
It's too much.
Right? So if you can run it reasonably fast and reasonably well using existing developer productivity engineering tools like
the velocity
test containers.
It's just testing you. It's just testing you.
Test containers and other simulations which are close enough to what you will have in CI.
Right.
But our lock and build, you will worry much less about what you ship to CI.
Right.
And you will be able to concentrate more, do better job, and be more productive when you do it.
Granted. I mean, we agree in theory.
Perfect.
In the abstract.
Now we are to the metal of two problems.
Okay.
There are two problems. First, if you build everything that you can locally, the build will be too fast. Too slow. Sorry.
I was going to say, that's not a problem.
Right. The build will be too slow.
Yeah.
And on the other side, if you try to make your build very, very fast, you strip important components of this confidence that we just saw about, like stripping test. So how can we do this win-win of checking as much as possible and doing it without interrupting your flow and making the build unsufferable?
Selective analysis of downstream impacted components?
Perfect. There are two techniques, generally, broader. The first is avoidance. Avoidance means we don't build, don't test, don't run what we can skip.
Right.
And by skip, we mean in high degree of confidence, we can say it didn't change or it didn't got affected.
Okay,
Right? And that means stuff like your incremental build in Gradle, in Maven, whatever you use, right? So it will analyze your project, your modules in the project, and it will say, you know what? This is core and this is API. API didn't, core didn't change API. We don't need to rebuild API. This kind of stuff,
Don't worry about it.
Don't worry about it. This is a very good start.
And by the way, that's also good for the turtles.
Good for, obviously, everything we say in the end of the day.
Spend less energy, save a turtle. I mean, it's very important.
It works beautifully together.
Yeah.
Because when we save time and effort and energy, it's good for everybody.
Yeah. Especially the turtles.
And our brains.
Yeah.
The two main components.
And our time budget.
And money, of course, always. So, so we avoidance. So this is a very naive avoidance. A lot of build tools do it in a naive way, but it kind of lacks a little bit in two areas. First is not everything can be decided to be skipped just by looking at produced artifacts or a module structure. Right. Because first of all, there are a lot of work in the build that is done that is not necessarily producing those artifacts, and we still want to skip it if it didn't change. And this is where caching come in. right? So smart caching that can cache everything, and sharing this cache among other peers of your team. So if you didn't build it,
But
they don't
somebody else
need to
did.
build it as well. Exactly.
Yeah.
You can use their cache, right? So caching is critical. Distributed caching is critical. That's number one.
Yeah.
Number two, tests. So as we said, your build tool can make assumptions.
Yeah.
Which tests don't need to run based on the structure. But if it decided that this module needs to be tested, all the tests of this module will run.
Sure.
Regardless of which exact code was changed and what are the chances that those changes will affect the tests, right?
Right.
And this is where stuff like predictive text selection kicks in.
What is okay? So explain.
So predictive test selection is a research done by Meta that says very simple things. Let's observe for the longest time how certain changes in the code affect certain test results.
Okay.
And then with machine learning, we can make conclusions that a test, that a change to a certain code in a certain way might not fail certain tests with a very high degree of confidence. And what it means then, that we can skip this test with a very high degree of confidence and save tons of time in our build and eventually save turtles.
Yeah, and if it's so that gets you over the hump on your local machine, and you still have the safety net of CI for that rare
For
1
those
in a million.
3%. Exactly.
Yeah, okay.
Exactly that. Right? Now, I'll give you some examples which are funny because it makes total sense for us, but for a stupid machine, they don't know. They just discover it. For example, a mind-blowing discovery by machine learning is that if you have files with extension .js,
It should not be trusted at all.
and you have files with the extension .java, when you try to refactor this code and this code, for some unknown reasons, the tests in the project with the files ended with .java, for some reason, fail much less than the tests in with the project with the extension of JS.
I wonder if the compiler has anything to do with that.
The thing is, you know why, and I know why, and our audience know why.
Sure.
The stupid machine has no idea. It just discovers some kind of correlations by observing tests.
Right.
And it's kind of funny how it works when it discovered something that is natural for us
Right.
through this machine learning. So yes, this is right. And then obviously it makes sense, like, okay, if we rename the file and we use the IDE and we do it like every day and the tests never fail,
Yeah.
let's just not to run the tests.
Right. Just it's fine. Yeah.
Now, you know what? Once in a million, we opened the notepad and renamed the file.
Oh.
And it didn't do full refactoring. It's fine. Our CI runs the whole thing. And it's fine that our CI run the whole thing. Why? Because it's asynchronous. You don't
Right.
wait for it. But the local build, and I mean, it will bite you in the ass. But once in a while, it's fine.
Yeah.
But on a daily basis, you will avoid build testing so much that
Yeah.
it will be definitely worth it.
Of course. Yeah, and literally in cash value, time saved, and productivity, it'll be worth it. Yeah.
And you remember your anxiety of how is my test CI doing will go down because you will trust that whatever you ship to CI is completely fine. Right. Okay. So this is avoidance. The other one is speeding up what you cannot avoid. In the end of the day, you wrote some code, you need to build it, and you need to test it.
Right.
Right. There is work to be done.
Right.
You
just want to spin up and test everything else. You just want to test your thing.
But whatever you did needs to be done. Sure. And here is where speeding up techniques come into play.
Yeah.
So there are a couple very profound ones. The first is using computing power of your machine. We were joking about how this machine can barely run Chrome and Slack, but this machine can actually speed up your build tremendously.
Right.
I have the same one, I think maybe one generation earlier, I have M1 with 64, but
Amazing machine, by the way. That's my all-time favorite machine.
right. So I have a build there that runs for 2 minutes,
Yeah.
just like doing whatever, just basic Gradle build. Now I change one line of code in my build, and it goes to 120 seconds to 6. Guess what I do?
Thread.
Yep. All I do is I add one line of code.
Okay.
Use maximum threads.
Right.
20 times savings.
Yeah.
20 times. Josh,
But will I still be able to run my Bitcoin miners if I'm doing all this building?
this you will need to do on your
I'll
your
do that in the CI.
exactly.
Okay.
But
good.
because it's
not doing anything anyway. I'm doing all the work here.
exactly right. So it's and now it's amazing the savings that you get by parallelization. Right.
Okay, I agree. Yeah. Threads are nice. They're going to be big one day. You just watch. I think they're going to go places.
Maybe.
Yeah.
Who knows? But yeah. So this is amazing savings.
Yeah.
And you will drive down the time of your build.
Mm-hmm.
But you know who has more threads than your machine?
Not CI. The cloud. Oh, the cloud. Yeah. The cloud.
The cloud has even more.
Yeah.
Now, what you can do is during your local build, you take all those tests that you need to run and you ship them to the cloud.
Is that not CI?
No,
Oh.
because it's your local build. It runs in the cloud, spinning up as much workers as efficient, because spinning up workers obviously costs something, and then collecting the build data costs something. In some point of time, spinning more is not going to do everything. But if it's the build is smart enough to do this math, should I run it locally or should I spin a couple of workers in the cloud?
I have questions.
Maybe the combo of the two is the most efficient.
Sure.
And then when it gets the results, it reports it back to your running local build on this machine, not the CI.
Right.
And your local build is even faster.
So it's a scatter gather kind of thing. Okay, question. How do the cloud instances have all the context required, like environment variables and things like that?
So this is all shipped with the from your build to the cloud.
Okay, so you have secrets and credentials running in the cloud? My secrets?
It's an ephemeral agent
Okay.
that is spun up to run your tests and then destroyed once your tests are done.
So it's like completely lost.
TSL, SSL up.
Yeah.
Just run over there. Results are back. The instance is destroyed.
And in plain fact, I don't usually have secrets there, but just in case, that's just
No. It's all fine. It's all over SSL, and it's an ephemeral agent that goes up, runs your stuff, goes down. In the end of the day, it's like Kubernetes, like tiny images the containers that spun up, and it's an ephemeral thing, right?
Sure.
Now, those two things of parallelizing on your machine and parallelizing on cloud,
right,
speeds up what cannot be skipped.
I like that a lot. Yeah.
Okay.
And that means I can still run the Bitcoin miners on my machine.
Yeah, of course, because then it will actually know that your machine is busy, so it will prioritize the cloud on your machine.
That's so cool.
It is pretty
cool.
It is pretty cool. It is pretty cool. So and then you have, you skipped everything that can be skipped, and then you sped up everything to the max, what needs to be done, and your build coming down from tens of minutes to single digit, to maybe a minute, maybe less, maybe a little bit more. Now, you remember I asked you how long what would you define a long build?
Oh, yeah.
What would you define a long build?
45 seconds. And the reason I know that is because most of my GraalVM native image builds take at least that long, and I get very bored. I get really cranky.
Excellent.
45 seconds.
The cranky part is critical. Okay, so I will tell you how to determine what the long build is. Long build is the build that you give up on waiting for.
Okay.
And it's different between people. You know, there are some people, maybe on a Spectre, that can watch a build running for 5 minutes. They don't have this urge to go and check their Twitter. We are not those people.
I am, after 45 seconds, I'm gone. I've left the office.
Perfect.
All
right. Okay.
I get so bored.
All right. Perfect. So for you, 45 minutes is...
Or seconds.
45 seconds is what defined a long build. And then you will switch to something else, and you will do something else. And give me a guess, on average, if you are like other people, how long it will take you to switch back to check if your build was successful?
How long it would take for me to switch back?
To check that the build was successful after you got distracted and start doing something else.
Oh, so once I had a really long build and I was working on something and then I got distracted. I left. Ended up going into the living room. Next day I had a flight. I ended up doing 2 weeks of travel. I came back and I was like,
To
oh,
check on
hey,
the build.
I should check on the build. So it took weeks. Yeah.
Yeah, no, I mean, on average, if you don't leave on a flight, if you just switch to check, if you had a retweet from J Baruch, for example, and then you plan to come back, how long it will take for you to come back?
I popped that stack so quick though. It's probably I'll never come. I mean, it does. So I'll check like in a few minutes. You know
Exactly.
But
So let me give you a number.
Wait, can I just?
Yeah, go for it.
Look, I talk about these long build times, and especially with GraalVM, and I did ask people, like I did ask Oracle if they could.
Right? Brilliant.
And then
share it.
Oh, I asked people if they could.
No, share the screen so people will see.
No, I don't want to, but I'll tell it. It's an Oracle GitHub issue where I asked Oracle to play elevator music during the native image compilation.
And they closed it, bastard.
I know, but I got some great responses. And this one, I always think about this one all the time. And this one is basically, you could use you can have like a beep sound, like the microwave.
Yeah.
So if my CI environment could just go ding, like the toast is done.
Yeah, not CI, your local build.
My local build, yeah. If all those things could have that like ding, then I wouldn't get so distracted,
right.
you know?
Right. This is brilliant. And they closed it. I'm outraged now. So I'll give you a number.
Okay.
Dr. Gloria Marks, she studied attention span for like 15 years.
Yeah.
And she released a book called Attention Span.
Okay.
This year that summarizes her.
Is it a very short book? It's got to be very short.
Good one. That summarizes her research.
Okay.
Now, one number I want you and the audience to remember from there. Average attention span to get back to the context of what you are doing after interruption is 25 minutes. On average, if you are like other people.
Wait, so that means, what does that mean?
It means that every build longer than 45 seconds is 25 minutes.
Right, which is terrible. Yeah, that's why I want a ding sound so I know to go back to it, because otherwise I'm gone. I'm gone, baby. I'm off to the next thing, and then the next thing after that.
Every build that is longer than your attention span is 25 minutes.
Is that so that's the average it takes most people who get distracted to remember, oh, hey, I've got a thing in the oven?
Yep.
Okay, see, this is why I think, look, a ding sound.
So you understand why speeding up your build below this threshold
is so important.
It's so important.
This is why, it's obvious. I'm glad there's research. I intend to read, I already forgot because I wasn't paying attention.
Attention span.
No, it's called attention span. I knew that. I intend to read this, but seriously, this is why people just despised WebSphere back in the day, right? Because it would take minutes just to spin up an app. 45 seconds, that's a light, quick startup for that thing,
Exactly.
If you want to just start the thing and it takes a minute or 2 or 5 or 10 or whatever, people are gone. They're gone.
This is developer productivity. And by fostering faster feedback, speeding up your build is the way to engineer developer productivity, because then I keep you focused. I keep you in the zone. I keep you moving forward. And then on top of that, once you shipped your build to CI, you are still focused on the next thing instead of, oh, my tests are not good enough.
Right.
Will the CI fail? Will the CI run? And be always thinking about that.
Right.
Because you have rock solid build, you know exactly, you can trust it, and it was so fast that you could wait for it without getting distracted, and you were more effective.
Right. And I will tell you though, you're right, 100%. And in my whole life, because I love continuous delivery, right? I'm a big
Exactly.
fan.
Yep.
And so everything I do is about fast feedback.
Yep.
Right. Microservices are all about fast feedback.
Absolutely.
Testing, in TDD, continuous integration, all this stuff. Cloud computing, even. It's
of course
quick and easy and cheap to I don't have
spin up stuff.
Yeah, I don't have to rack and stack a server.
Yep.
All that's great. I love the fast feedback, but I will tell you one thing that has helped me with my attention span is that the news is too terrible to look at, so I don't get distracted and go check out the website.
Instead, do something else. You watch Kitty's videos.
Like cartoon videos?
Kitties, like cats.
Oh, cat videos. Yeah,
Yes,
yeah. Yeah. I mean,
and if you don't, you really should. It's really good for your mental well-being.
oh, I do. Every now and then the algorithm, because my algorithm is, I've got it. So so let me try again. My daughter sometimes uses the Netflix that's signed in, my Netflix. And it's cursed now. I can't watch my own Netflix account. It doesn't give me anything I want to watch.
But this is why they have profiles.
I know she doesn't use it. Okay. And so I'm like, okay, which is fine, but Netflix is gone for me. I don't use it as a thing anymore.
I hear you.
So I won't let anybody use my YouTube.
Yes.
Because I'm scared if they curse my algorithm. Right now,
the recommendations will be absolutely insane.
And I have a delicate blend, like a fine coffee or a fine wine of composite grapes.
Over the years,
handcrafted, artisanally crafted YouTube algorithm that gives me like 20% video games, 40 to 60% software, and the rest of it is just cute animals.
Yes.
Right?
Yes.
And if I won't
protect it.
I will protect it at all costs.
All costs.
And this is why I can't use the Twitter.
Right. No, Twitter. No,
this feed is cursed.
No, this thing is done. We read the people will follow, and then we not looking.
Yeah. Just don't click on anything.
Exactly.
Just don't breathe on it. It's terrible.
Yeah. No, the people we follow, we keep reading, and they're awesome. Yeah. I follow Josh, and he's amazing.
I can follow you. And sometimes we have to keep refollowing each other because even before the Bird website went down,
whatever.
We used to get disconnected.
Yeah. So in any way, keep focused by foster faster feedback.
Yes.
I guess that's kind of the takeaway of our today's episode.
I'm gonna change the title.
Yes.
I'm not sure if I can without having to. I'll do it on YouTube.
Yeah. But it's foster faster feedback should be the title of today's conversation.
Yeah.
Exactly.
Okay.
Yeah.
On that bombshell, this has been great. Hey, man.
It's been a pleasure.
By the way,
yes.
If you want something that'll do all that stuff for you, you have two choices. You can hire a team or just use what used to be called Gradle Enterprises, now called Develocity, and it's dope. And it's a thing that works with Gradle, but also the Maven.
Yes.
Yeah.
And Bazel and Scala.
Yeah.
SBT. Yeah.
Neat.
God forbid. Yes.
Yeah. And how much is it? Like, is there like a pricing tier I should know about?
I guess. So, all right. So first of all, there is absolutely free tier that's called Gradle Build Scan. Gradle Build Scan gives you visibility into what your build is doing.
Yeah.
Caching is absolutely free.
Okay.
Local and distributed remote caching, as long as you spin up your own cache node, which is an HTTP server.
Okay.
For your team. This is all free, right? Okay. The stuff that your boss should pay for is the predictive text selection, right, and distributed testing.
Okay.
Local multi-threading, local distribution on your machine is also free. So I would say out of whatever 6 things we mentioned, 4 are free.
Nice.
Yeah, which is you can start using them today. Absolutely.
So that's what I think. I think the question people are going to have is where because by the way, you could just do it all yourself. These are all things.
Oh yeah. No, I mean predictive text selection kind of hard because it's machine learning and stuff. But the algorithm is there. I mean, Meta published it for free. Yeah, so if you want to do it, go for it.
You could.
Yeah, but you should.
But you could. By the way, we don't on the Spring team. We use Develocity. Spring Boot uses it. We've had great results.
And you can see Spring team's Develocity by just going to GE, which stands for Gradle Enterprise .spring.io.
Yeah.
And you will go to, if you do it, if you want to take a look, the most fascinating tab over there will be the predictive text selection.
Yeah.
Because those guys run
and gals,
of course, those folks run it in simulation mode.
Yeah.
Now,
run.
Right. I would be annoyed with y'all for doing that, but I'm not, because it serves me perfectly. You know why? Because only in simulation mode, you can really see how precise the model is. Right. Once you switch it to production, you don't know. It will get some, but you don't know how much it will miss, right? In the simulation mode, it does the predictions, and then it compares it with the results that you run with the test that you run anyway.
Right.
So you can see those insane 99.8% accuracy when you go to ge.spring.io and go to predict test selection. I use this instance as a demo for it every time. Please don't use it. I'm just kidding. Please do. Much more important than my demo abilities is your developer productivity.
And we're good. We like it. We're fans. You twist our arm, So Okay, now on that bombshell.
On that bombshell, what I wanted, now, if you want to hear more of Josh and me rambling about stuff, you should watch another show that it's called the Build Proportion Lab.
Yeah, BPL.
BPL. Build Proportion Lab is what's it's called, not a channel, a playlist on Gradle YouTube channel,
Right.
in which we stream live interviews like this, but obviously much more highly in much better production. I try to pull Josh into higher production standards. Look, we're using proper microphones today, but in Build Proportion Lab, it's like 3 cameras and spotlights, and it's crazy. So yes, next time we'll do it will be at Devox Belgium.
Right, and we did last one in Devox France.
Exactly, when we will do Build Proportion Lab, and Josh will come and I will host him, and we'll probably talk about the other side, which will be Spring Framework.
I think that's going to be
Spring
fun.
Boot, and how awesome that is.
Good stuff.
Good stuff.
You're my friend. I know where to find you, but what about them? Where do they find you?
At J Baruch. At J Baruch everywhere.
JBARUCH on the Bird website.
Everywhere.
On Instagram.
Everywhere.
Is it jbaruch at jbaruch.com or
it's jbaru.ch, because I'm smart like that.
The Swiss one. Oh, that's nice.
Yes, it is. It is. A Swiss domain does me a great service. Yeah, so it's just J Baruch.
At jbaruch.sh.
jbaruch.sh. Yeah. Now, if you want to see more, if you want to hear more about developer productivity engineering, speaking.jbaruch will take you to a website with a lot of talks about this topic, including everything we spoke today, but much more. Stuff like behavioral psychology applied to developer productivity engineering. Stuff like surviving the layoffs through the aspect of developer productivity engineering. Stuff like DevOps through the lens of developer productivity engineering. There is a lot of things to unpack.
You should get an interview with the author of that book, Attention Span. She would be really interesting to listen to as well.
You know what? I'll try to ping her. Let's see if she pays attention.
Okay. Bye, everybody. Bye.
Bye.
Thanks, buddy.
It was awesome.